Hi everyone. Today we're going to be talking about transformations in geometry, which is a movement of a shape which is congruent to the regular image. The actual image doesn't change. When we did dilations, the image got bigger and it got smaller. That's not what we're looking for here. A transformation doesn't actually change the shape at all. It just changes where it's located, its location. So the first one we're going to look at is a translation, which is just a fancy way of saying a slide. So it's a slide without it turning. The second transformation is a rotation, and that is a turn. So it can rotate around a point called the center of rotation. It's simply a turn. And then a reflection, very much like a mirror, or if you were to fold the paper right on this line, the two triangles would match each other. So reflection is it's a flip. So translation is a slide, a rotation is a turn, just a fancy way of saying turn, and a reflection is a flip. The resulting image is congruent to the original figure, so it does not change its shape at all. Now, we're going to be worried about the coordinates because we're going to be working on a coordinate plane this whole time. So a slide, what happens to the coordinates? So let's go into the details here. A translation, which is a slide. All right, we're going to be talking about what actually happens to the coordinates. So the first one, in a translation, and what I have here is an up and down. So a vertical movement. What changes? Well, let's think about this. If something changes vertically, then your x would stay the same, and your y would be the one that changes. So I'll just say y changes. Whether that is an increase or a decrease, it would change. Similarly, if we're talking about a slide side to side, our x is the one that's going to change, and then the y is the one that has to stay the same because it's not going up or down. A rotation is a 180-degree turn. And what happens when it completely turns 180 degrees is that you have whatever it was before gets completely changed. So what was positive now becomes negative, or what was negative now becomes positive. So they become their opposites. And in this case, if I had them both being positive, all of a sudden they would both be negative, okay? That would land them in the third quadrant. Now, it just depends on where your picture is drawn, but a rotation would turn them like that. If they were once negative, now they're positive, and vice versa. A reflection over the x, literally a flip over the x-axis. So remember, if I said if there's any change that happens over the x, the actual x will stay the same, but then the y will change. So what would happen would be the y would be flipped. If it was negative, now it's positive. If it's positive, now it's negative. Similarly, with a reflection over the y-axis, the x would change because the y is not going to, how high it is would not, and then the y would stay the same. So let's talk about this a little bit. We'll have an example of, let's say 5, 4 is my point, okay? So I'm going to go backwards from where we were. So a reflection over the y-axis would be, now it becomes the opposite of the x, so -5, 4 would be my coordinates. If I reflection over the x-axis, my x would stay the same, my y would become negative. If I had a rotation, both points would become negative. And then a translation, a slide. So let's say I wanted it to slide to the right 2 places. So my x would change. It would now be 7, because I said 2 places, but my y would stay the same. And let's say if I wanted it to change 2 on the y, my x would stay the same, but I want it 2 up, going up 2, that would be up 2 on the 6. So let's practice these. All right, we're going to identify the following as a translation, a rotation, reflection, or none. So in the very first one, to me, that looks like if I were to draw a dotted line here, it would be a reflection. It would be a complete flip there. So I'm going to write reflection. Okay, these I always think look like Dorito chips. I'm going to color it in kind of like a Dorito. This, I would say, is a turn. This would be your rotation. It's like I had it and completely turned it, okay? Next one, they want us to do a little bit of a drawing. So we are going to, and not just that random line I drew, but we are going to do a drawing in the exact way they want us to. So it says here, we want a translation, which means a slide along AB, that side, so that the new A coincides, which means on top of or lines up with B. So a slide along AB. So here's AB. Do, 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 do. If I continue, it keeps going this way. So that the new A coincides with B. So remember, when we're doing a transformation, the actual shape doesn't change. You may say, Mrs. Nettles, this is a horrible drawing. I would agree with you, but the shape should not have changed. It's a slide so that the new A lines up with B, and it just slid along that AB line. Next, we're going to be taking a picture and actually changing where it is, transforming it. And in this one says, draw the image of a triangle with vertices of 1, 1, 2, -2, and 5, 0 after the transformation. So it says 180-degree counterclockwise rotation along 0, 0. I don't want you to worry about this. We're only going to do 180-degree rotations along the origin, so nothing's going to be too fancy here. Stick with what I had told you before. So if it's a rotation, you're going to change them the opposite of the x and the opposite of the y. So 1, 1 instead of 1, 1 is going to be opposite of that. Opposite of 1 is -1. Opposite of 1 is -1. This should be pretty easy. Opposite of 2 is -2. Opposite of -2 would back to being +2. And then 5, 0, the opposite of 5 is -5. Now what would be the opposite of 0? Just 0. Now we're going to plot the new points. -1, -1. So that's here. -2, 2 here. -5, 0. So this would be a turn. Oh my gosh, that last line was terrible. I better erase it. That would be a turn, a rotation. Okay. The next drawing that we're going to do is a reflection. So it's literally like I took my paper and I'm going to flip this image over the axes. So it's going to be like the mirror image over this axis. So what happens is when I'm going over the x, the y is the part that changes. The x actually stays the same. The y is the part that changes. So let's go through the points and change them exactly how I said. X stays the same. So the first one, -3. But y changes. Now it'll be -4. The next point will remain -1, but then the y changes. Instead of +6, it's going to be -6. In the next one, instead of, so 3 stays the same, and then instead of 6, I have -6 again, and then 5 stays the same, because remember the x stays the same when you have a flip over the x, but the y changes then to -4. Now we're going to draw our new points. Now remember, the image should not change. If all of a sudden you're getting a smiley face, something's wrong. If you get a circle out of this, something's wrong. The image should not change. It should remain the same. It's just going to be in a different spot. So -3, All right, so now we're going to start graphing. Like I said, if you get a shape that doesn't look like the original one, something is wrong. Shouldn't be a smiley face, shouldn't be a circle. It should be exactly what the shape looks like. So the first point is going to be at -3, -4, -1, -6, 3, -6, 5, -4, and then we're just going to connect the dots. It should look like exactly what we said, a reflection over the x. Does it look like I folded this line and now the two images line up? Yes. If something's out of place, you graphed it incorrectly, which is easy to do and an easy thing to fix actually when you go back. We have two more we want to go through. It says draw the image of a square after a translation of 6 up. So all we're doing is moving this square up 6, okay? Now, should it change the picture? Should all of a sudden the square become a circle or some sort of other shape? No. It's still going to be the square. It's going to look identical, but just in a different spot. So we're going up 6. So does the x change? The answer is no. I'm going up 6, so it should be y plus 6. All my y coordinates are going up 6. So I have -2. Now I'm taking my y coordinate, which is -2, but then I'm adding 6 to it. -2 plus 6, and if you need to use your calculator, by all means, please do. -2, 4 would be my new point. My second point, the -5 stays the same, and -2 adding 6 to it would be 4. And then I have -5, -5. Remember, the x-coordinate does not change, but we're moving it 6 up. -5 up 6 would be 1. And then -2, -5, -2 stays the same, and then it'd be 1 again. So let's graph it and make sure we did it correctly. -2, 4. -5, 4. -5, 1. -2, 1. Let's make sure this square looks basically the same. I mean, minus my poor drawing skills. But is it a 3 by 3 square? Yes. Does it look like all it did was move 6 up? And that's correct. And our last picture we're going to look at, it says identify the 2 transformations that the following triangle has undergone. Because sometimes we can move the picture more than once. So in this example here, we're looking at the blue. How did it become the red picture? Well, the red picture looks like it's in the 3rd quadrant. And it says it had 2 transformations. So my guess is that it flipped or reflected over the x. And then it looks like then maybe it had a slide or a translation to the 3rd quadrant. So let's check, see if we're okay on this. So where do we think C landed? C would have been here. And then B would have landed here. And then A would have landed here, making this a flip. This would have been a reflection. This is what you would need to say if this was a homework. A reflection over the X. And then what happened? It's a slide, which I should use the fancy word here. The translation. How many over? Looks like 5 to the left.